Hey there YouTube, my name is Ash and I'm here to help you crush your coding interview. I've been a professional software engineer for over 16 years. I worked at Amazon and I've interviewed with mostly other big tech companies, so I've definitely learned a thing or two about coding interviews, and I'm here to pass on everything I've learned through trial and error so that hopefully I can save you a few headaches and help you succeed in your coding interviews sooner rather than later. Today we're going to be looking at one of the most common data structures that you're going to run into on coding interviews that's rarely ever discussed in a computer science class. I'm talking about the trie, or also known as a prefix tree. And I think one of the reasons that this is so popular in coding interviews is because it's something that we use every single day. When you pull out your cell phone and you start typing out a text message, you'll notice that it auto-suggests or auto-completes some of your words for you, right? So this is something that we're so accustomed to, it makes a really good coding interview problem because it's really easy to explain to the candidate and the interviewer has no problem giving real-world examples. All right, so what we're gonna do is we're gonna first talk about what a trie is, how it works, and then we're gonna dive into implementing one in JavaScript, and we'll implement both the insert function as well as the autocomplete function, which are probably two of the most common things you're going to run into if you run into a problem like this in a job interview. All right, so what we have here is we have a trie with a dictionary of 3 words. So in my dictionary, I've got dog, bat, and cat. And up here, I've got a root node, and the root node is actually almost just like a placeholder. It has no value. It simply acts as a pointer to all of its child nodes. So here you can see I've got one node off the root node with D, and then it has an O child and a G, and here I have B, A, T, and C, A, T. Now each of these nodes can have up to 26 different children, one for each letter of the alphabet. And so you can see how you're walking through here to complete words. You'll also notice that I've got a Boolean value here in addition to the character that each node represents. The Boolean implies whether or not this is a word. So you'll see D, O, and then G, we have a true because we're counting D and O as not being words simply because the word do is not in our dictionary. However, dog is, so we have a true at G. Same here with B, A, T. We have a true at T simply because we have to walk all the way down here to get to a word that's in our dictionary. And likewise, you see that with cat over here with C, A, T. Now, unlike a typical node that you might have run into, you've probably run into a lot of binary tree nodes, right? So you've got a value, and you have a pointer to a left child and a right child. Here, on the other hand, we have a value, and then we have this Boolean I was talking about, right, which I called isWord, which will always set to false. And then we have this.children, which represents all of those child nodes, right, up to 26. And I'm just going to go ahead and use an empty JavaScript object. You could use a JavaScript map structure for this, but in this case, I find a JavaScript object is so convenient that we're just going to go with that. All right, so I've got my whiteboard flipped over, and I've written out just the basic start of the trie class with a root node drawn over here, just so that we can walk through this graphically as we build this out. So as you can see, my constructor for my trie class simply sets a root property to a new trie node with an empty value. Like I said, this root node doesn't exist for any reason other than for us to get a pointer to the very top of the tree so that we can then walk down all of its children and see what words exist within our dictionary. But in order for there to be any words in our dictionary, we have to first create our trie. And we build this using the insert function. So let's go ahead and just define a simple function called insert. And typically, this can take either an array of words or a single word. In this case, we'll just take a single word and assume that if we had an array of words that we wanted to insert, we would just do a for each across that array and call insert on every single word in the array. So insert is going to take, we'll just call it a word. And word is just going to be a simple string. And what we'll do is first we'll check for our edge cases, right? So as always, we'll say if not word, right? So if it's either null or undefined, let's just go ahead and return. Now, always double check with your interviewer as to whether or not they want you to just return undefined like this, or if they want you to return some special value in the case that you have a bad parameter coming in. Next, what we'll do is we will actually start at the root node, like I said, right? So we'll say n equals this dot root. And then we're going to walk through every single letter in this word that we're passed in. So if it was dog, we'll go D-O-G. The way we'll do this is just a simple for loop. So we'll say for let I equals 0, I is less than word dot length, and then I plus plus. Okay. All right, so as I was saying, what we'll do is we're going to walk through every single character, so let's just go ahead and grab the character that we're on. So we'll say const C equals word of I. One nice thing about JavaScript is even though word happens to be a string, we can index it just like an array. Then we'll say, do we have a child for this particular letter of the word? And if we don't, let's go ahead and create a new tree node and have it be the first child, right? So we'll go ahead and do that by saying if not n.children dot has own property of C. Now, this might look a little bit confusing, but all I'm saying is the current node that we're on, start off as root, does the children object have a key corresponding to C, which is the current letter as we're iterating through this word in this for loop. And in this case, we put a negation because we're saying if it doesn't, that's okay. Let's just go ahead and create one now. So we'll say n.children of C equals new trinode of C. And then you can go ahead and come outside of this if. And we know that once we're past this if, we have a child node that corresponds to this letter. So whether or not we went into the if, we can now go ahead and say n equals n.children of C. And the reason we do this is as soon as we've processed one letter, we want to process the next letter, but that next letter is going to be a child of the letter we just processed. So as we're doing this insertion, we're actually walking through the tree. Now, all right, so the final thing that we want to do is we want to check to see whether or not the letter that we're currently processing is the final letter in the word. The reason for this is if it's the last letter in the word, we want to set that is word flag to be true on that final node that we create. So we can do that here at the very bottom by simply saying if I equals word dot length minus 1, we can go ahead and say n dot is word equals true. And then we're done with our insert method. All right, so as always, as soon as you finish writing some code, the very first thing you want to do is walk through some examples, both to satisfy yourself as well as the interviewer, to let them know, hey, look, this code I just wrote, let me walk you through it and demonstrate that it actually works. So let's assume that we want to insert the word dog. All right, so we'll start with the letter D. As we go through our word here, well, our word is defined, n equals this dot root, so we go into this for loop, and the first letter that we hit is that D. Now, n, which is currently the root, has no children whatsoever. So it doesn't have any kind of a D node. And so we're going to hit this right here where we're going to say new trie node with the letter D. So we can go ahead and draw that. And we know that isWord will default to false. Now, here we'll say n equals n.children of C, which actually has a value of D. So now n is pointing at this node here. We check to see if we're at the last letter. We're not. So we come back to the start of this loop. And we now process the O. And we say, well, are there any children corresponding to the current value of n that happen to have a key of O? There aren't. So we'll go ahead and insert a new trie node. Now we've got O also with false. And now n equals n.children of C, which equals O. So n is now pointing at this node. Then we'll finally get to the last letter, which is G. And of course, we have to create one. And since in this case it is the last letter in the word, we'll go ahead and set isWord to be true. And you could similarly walk through a couple more examples, and I would encourage you to maybe even try some edge cases. So for instance, we have dog. You might try doggy, just so that way you have a word within a word. You have D-O-G, and then you'd have another G and a Y. And so that would be an interesting edge case to make sure that your code works. And if you look at the unit tests that I've included with the sample solution, you'll see that I went through a number of different cases. So I strongly encourage you to take a look at the unit tests, run them on your computer, and make sure you understand how this code's working. All right, the next step is going to be actually implementing the autocomplete. This is going to be a good deal more code, so you might want to go ahead and click on that GitHub link down below and pull that code up in a separate browser window so that you can follow along. It might be a little bit difficult just given the sheer amount of code I'm going to be writing for this next one. All right, now we've gotten to the autocomplete. But before we jump into code, let's talk a little bit about how this is going to work. Now, an autocomplete function is just going to be a function off of that trie class that we built earlier. And it's going to assume that we've already built up our trie by calling insert on all of the words in our dictionary. So in this case, I took our example from before and I added the word door. So now we have dog and door in our dictionary. And so off of the root node, we can walk D-O-G or D-O-O-R. And so what our strategy is going to be for the autocomplete is we're going to take whatever fragment is passed in. So let's say that the fragment that's passed into our autocomplete is the letters D-O. And now we need to return all of the words that could be a valid autocompletion for the letters D-O, assuming this dictionary. So what we're going to do is we're going to start at the root node and we're going to walk all the way through that fragment. So D and then O. And from this point, what we're going to do is we're going to say, all right, we've walked down our fragment. Now let's do a depth-first search of every single node up to and including this word that was the last, or including this node that was the last letter of our fragment. And then let's return all of the words corresponding to those nodes. So we're going to first walk the tree through our fragment, and then we're going to do a depth-first search. Now you could do a breadth-first search. I prefer depth-first search just because there's no recursion, and it's just a simple queue. The results will be the same either way, but we're just going to do it this way. So let's go ahead and get started. So we'll define our autocomplete. And it will take a fragment. And this is just a string. As always, we'll say if not fragment. So if it's null or undefined, we'll just go ahead and return right now. On the other hand, assuming that it is defined, we'll go ahead and say, first of all, let's go ahead and create a result variable. And we'll just initialize it to be an empty array. And throughout this entire function, we'll go ahead and fill this array with all of the different words that we could autocomplete. And at the end, we'll just go ahead and return our result. So let's go ahead and start off at the root node. All right, so what we're going to want to do, now that we have our reference to our root, is we're going to want to walk through the entire fragment. So like before, we'll do a for loop. Say for let I equals 0. I is less than fragment dot length, and then I plus plus. Okay. Now within our for loop, we will want to first get the character that we're currently looking at. So we'll say const c equals fragment of I. So this would be the ith letter within the word, or within the string fragment. Next, we're going to do something a little bit different than what we did before in our insert. Namely, we're going to say if this doesn't exist, we're just going to break. Because if we're unable to walk through the entire fragment, then that means there's nothing in here that we could autocomplete. If that doesn't make sense, let's think about it this way. If we only have the words dog and door, and somebody types in the letters cat, well, as soon as we get to the C, we say, well, there's no child node here corresponding to the C, so there's nothing in our dictionary that'll autocomplete for the fragment cat. So the way that we'll express that here is we'll just simply say if n dot children dot has own property C will simply break and stop the entire search. Next, what we'll do is we'll say, assuming that we were able to find that child C, let's go ahead and walk down to the next node. So we'll say n equals n dot children of C. Now what we want to do is, before we go up to the next iteration, we want to go ahead and see if we've actually gotten to the last letter, because at this point, if we've gotten to the last letter in our fragment, we can start doing our depth first search, because there won't be another iteration through the for loop. So we'll say if I equals fragment dot length minus 1 means we've hit the very end of our word, and we can start doing our depth first search. So we don't actually have a convenient Q class in JavaScript the way that we do in a lot of other languages like Python. So in this case, I'm just going to use a simple array, because an array has a method called push, which appends to the end of the queue, or array in this case, and it also happens to have a method called shift that will pop the first item off of that array and return it. So much like we would have a push and a pop within a queue, we also have a similar thing here with an array. So let's go ahead and just say const q equals an empty array. And then we will first, before we do anything else, push the current node on there. So we'll say q dot push. And what we're actually going to do is we're going to pass in an array. So we're going to pass the current node, which corresponds to the last letter in the fragment, and we're going to pass in the fragment, because that's what that last node corresponds to. Now, that might not make sense, so let's come over here and look at what this means. So if we got the fragment do, we've gone d and we've gone o, and what we know is that this node right here corresponds to do. That's the word that this node corresponds to. Now, it's not actually a word because the isWord property is set to false, but we'll go ahead and push the fragment on there just so we know that if we had gotten here and it was a word, that fragment is what it represents. Next, we'll start processing through our queue. So we'll say while queue.length, and this is basically a fancy JavaScripty way of saying as long as queue.length is greater than 0. I really wish you could do while queue, but for some reason an empty array in JavaScript is considered to be a truthy value. I'm sure there's a good reason for it. I don't know why. Anyway, so while we have more items in our queue, let's go ahead and pop the first one off of the front using that shift function I was talking about. So we can go ahead and say const element equals queue.shift. And this will actually pop the first item off of the queue and return it and assign it to element. So now let's go ahead and get the node and the word fragment that this corresponds to. So we can go ahead and say const node equals element of 0, and then const word equals element of 1. Now remember, in our queue, we're always pushing in 2 items inside this array that correspond to this element. The first item is always going to be a node, and the second item is always going to be a string that may or may not be a word. Now what we're going to do is we're going to check to see whether or not this word is a word by saying if node.isWord, then we want to go ahead and add this word to our result array by saying result.push word. So hopefully you're able to see what we did right there. For every single item that we process in our queue, we get a node and we get a word that corresponds to some string. And since the node happens to have an isWord property, we can check to see whether or not this node represents a word. And if it is, hey, we have that word right here, and we'll go ahead and push that onto our result array. Now the final thing that we need to do in our while loop is we need to add all of the children of the node that we just processed to the queue so that they can also be processed as part of our depth first search. So I've kind of run out of room here at the bottom of my whiteboard, so I'm going to do what I always do during a whiteboard interview when this happens, and I'm just going to draw a little line up here and say, oh, okay, I'm going to continue my work over here. So the thing that I just mentioned was we need to iterate through all the children of this node and add it to this queue. So imagine that this code is happening right here. So we'll say for const j in n.children first, let's go ahead and get the child that this corresponds to. So we'll say const child equals n.children of j. So this way we're getting every single child node in n.children using the key, which is represented by j right here. So once we have this child node, we want to figure out what word it corresponds to. So let's go ahead and say const child word equals word plus child dot value. So what I'm doing is I'm taking the word that we have right here, and I'm taking the value that corresponds to the letter represented by this child node, and I'm concatenating them together to create this new word called child word. And then I'm going to add both of those to our queue, using the push method. So q.push child and child word. Apologies for the readability there. Like I said, please click the GitHub link down below and grab the code. I promise it's going to be much more readable than this right here. I'm doing this largely to walk you through my thought process, because getting a big chunk of code, not really knowing what the person was thinking when they wrote it, can be a bit of a nightmare when you're trying to also understand the algorithm and the data structure. So, at this point, we're done with our for loop, and we actually can then close off the while loop, the if loop, and this for loop. So it might look a little weird here, but I'm actually just closing off all these loops, and then I'm going to go ahead and return result. And that's our entire autocomplete function. Now, as before, let's go ahead and walk through this, assuming that we got a fragment with the letters D, O. All right, so we definitely got a valid fragment. So let's come down here. We have an empty result array initialized, and then we set n to be our root node, and then we start walking through the fragment. First, we have C, a fragment of 0, which ends up being the letter D. Well, we see that we definitely have a D right here off of the root node, so we don't break. Instead, we say n equals n.children of C, which corresponds to this node, and so now our pointer for n is pointing to this. So then we say, all right, I equals 1, fragment of I ends up equaling O. Is there a child off of D corresponding to O? Yes, there is. So we walk down here. Now at this point, we've reached the end of the fragment, and so we can start doing our depth first search. And we're going to start doing our depth first search right here, right? So when we come into this if loop, what we're going to say is we're going to initialize our queue to be an empty array, and we're going to push this node with the fragment DO onto the top of our queue. And then, while the queue has elements in it, which right now it has one element, we'll grab that first element, which corresponds to this node and the fragment DO, and we'll grab those two items off of there. So in this case, this node corresponds to this node, and this word corresponds to the word DO. Then we say if node.isWord. Well, is this a word? No, it's not. So then we'll go ahead and we won't add anything to our result array. But we'll come. Okay, so at this point, we're ready to start iterating through all of the children of the node that we're processing and adding them to the queue. Since we just processed this O node, we're going to add each of these nodes to the queue. And first we're going to say this child node here corresponds to a G. We're going to concatenate the word letters DO with the G, so we get dog. So we add this G node right here along with the word dog. Next, we come process this child node, and we say, oh, okay, well, it corresponds to DOO. So this child word is going to be DOO. The child node is this node right here, and we'll add that to our queue, and we'll say q.push child corresponding to this node with the word DOO. Now, we've processed all of the children of this particular node, so now we go back to the start of our while loop. The first item in our while loop is going to be this node that we processed as the first child, and we look at it and we say, okay, well that node corresponds to the word dog, and node.isWord is set to true, so we end up adding dog to our result array. Next, we come over here to our for loop and we say, well, does dog have any child node off of it? And that G node does not have any children, so we don't even do anything in this for loop, and we come back to the start of our while loop. Our while loop now processes the other node that's in our queue, which is this node right here. And so it says, okay, that node corresponds to that letter O, the word corresponding to that is DOO, node.isWord is false, so we won't add anything to our result array, but we will come up here and we'll now process this child node and add it to our queue. So in this case, we have DOO plus the child.value, which comes out to DOOR. So we end up pushing onto our queue this node with the word door. And then we come back to the start of our while loop. And the only element left to process is this one. And we say, okay, well, this node corresponding to the R has the word door, and node.isWord is set to true, so we'll add door to our result array. And then there's no child off of this R node, so we have nothing to do other than to get to the very end of our function and return result. So what we've done here is we've walked through our fragment, DO, and then we've done a breadth-first search of everything underneath here, and we've returned all of the words that correspond to nodes which have an isWord property of true. So in this case, we've returned the words dog and door because somebody entered a fragment of DO. Now, in addition to walking through that example, I would make sure to walk your interviewer through at least one more example that has some kind of an edge case. So perhaps, let's say somebody typed in cat, and what happens in this case when you don't have any kind of node that corresponds to any of that fragment, right? So just walk them through a couple cases to get them comfortable with the fact that you have implemented every single part of this function, and that also gives them the opportunity to either A, point out any edge cases that you might have missed, or B, complicate the question further. That might sound like a nightmare, but this is actually a sign that you're succeeding. If you go through a coding interview problem and the interviewer says, oh wow, we still have time left, do you mind if I add another edge case or maybe add another requirement? This is actually a really positive sign. It means that the interviewer knows that you have completed this entire question that they've asked you, and now they're just pushing you to see how much further you can go. And it's actually a very positive thing, as negative as it might feel in the moment. All right. So that was a full autocomplete in JavaScript, walking through the Trie implementation, and hopefully it made some amount of sense. I understand this is probably going to be pretty confusing the first time you see it, and I strongly recommend that you go pull down that source code. I've included the link down below, and please go ahead and run the unit test locally, alter the unit test, maybe even alter the code to see if you can maybe pull out that JavaScript object I was using for the children, maybe replace it with the JavaScript map. The key thing is to make sure that you can do this on your own using nothing but pencil and paper so that you feel comfortable when you go into the interview. All right, thanks for watching, and I wish you all the best of luck with your coding interviews. Man, whoever thought that a doggy door was a good idea? Because it's like, oh yeah, this way people can rob us, but they won't break our windows